So, our next speaker is Milica. Um, I need to tell you a little bit of a background story about Milica, and also one of the reasons why we are super proud of the TX conference. She was actually one of you guys during the 2022. She joined as attendee, and she was so impressed with everything that we are doing here that she decided to join our company after the TX conference. And 1 year later, she already was a speaker at the TX conference together with Milena. But this year she will present alone. So well done, cheers for you. And Milica is also a junior data scientist at TX Services. She has so many qualities and so many different hobbies and interests. It's really amazing what that girl knows and what she's capable to do. But what she will talk about today is actually her master thesis. So it's a lovely introduction as well for Oscar, who is our next speaker. But I really hope that you will enjoy this talk as much as I did while we did the preparation session. And Mitika, stage is yours.
Yes. So, as Milica mentioned, I will talk about my master thesis and I will guide you through this timeline, why I choose agriculture, what is a big project that is running in background, which data and algorithms were used, which results were achieved, and in the end, a really important field of explainable AI, and we will try to draw some of the conclusions. So, at first, why agriculture? I guess we all have relatives, family, friends who are living outside of the cities in smaller villages, and they usually have small gardens, small garden, yeah, in a backyard where they are growing their food naturally. And my first thought was, how can I help them to retain the same quality of the food, because I think that's a privilege to have food like that, but in order to optimize their time. And first, there was one use case where we used smart navigation irrigation systems, and that's one of applications which you can do. And then I decided to dive deep into AI, how actually AI can help us with this field, and what are some of the use cases. Of course, to predict crop of the yields, which is standard procedure in data science. Then also to do optimization of not just irrigation system, but pesticide application and so on. But what I was curious also about is one small village near my hometown, Zrenjanin. It's called Klek. I don't know if you're familiar with it. Yes, I know you are. And that was Olympic village. Braća Grbić are from there, Bodiroga, and so on. But sport was very popular until 2020, something like that. And 15 years ago, they started to grow a lot of illegal farm types there, such as cannabis. And, and yeah, I was curious how nobody is detecting it. And with latest information, they caught all of them, and it's not possible anymore to grow, at least they're near Bagay River. So I wanted to see how they can catch those illegal farming systems. And now we will talk about that project. It's a really huge project called Copernicus, which is a project of European Union and European Satellite Agency. They constructed two satellites, Sentinel-2A and Sentinel-2B, and they were launched in 2015 and 2017. And they can help us to capture all the information about forests. Of course, if there are illegal cuts in forest, they can track that. They can map disasters after earthquake, hurricane, floods, to see how the crops are doing, how they can make a faster recovery. They can do a lot of things. How? Because those satellites are capturing the images of the earth, of water, and coastal areas. And we all have access. You will soon see how. But this is to have a better idea of how the satellite looks like. And it consists one instrument called multispectral instrument, which is predefined to capture 13 different spectral bands in a different colors. And that's how it can capture all the images and send us back the images of all the areas and fields in which we are interested in. And what we are getting as output is this type of the data. So we have visible, near infrared, and short infrared, shortwave infrared spectral bands to capture those that electromagnetic spectrum on a resolution of 10, 20, and 60 meters. And you have features, for example, B2, 3, 4, and 8. And some of them are used for urban planning in cities when we have the overview of those terrains. Also, spectral bands on 20 meters can help us to better understand the vegetation state. Are crops enough healthy? What is the level of chlorophyll content? Also, for soil properties which are important to track. And then on those on 60 meters are usually used for cloud screening. I know this is a lot to understand at first. It took me quite some time when I got the data from Bioscience Institute to actually learn how they are performing and what can I get as information from some of the spectral B feature, because my mathematical background is that it's just one some numbers, but I needed to dive deep into research part and even in a biology part to actually understand what is happening here. And for example, also some of them you can use to capture they can only some of them can penetrate to clear water to get information about the crops in a water areas and so on. And as I mentioned, this is you can all download the data. How? It's open access hub, and if you go and visit Copernicus website, you can choose actually the tile in which you're interested in, and then select, for example, this area around Belgrade, and then you can download the data and get the informations about those fields. And since I mentioned this was my master thesis and collaboration with Bioscience Institute, I already got the data which was prepared. And the data was not in an image format. They already converted it into pixel formats. And all files were in CSV because the analysis was later done in Python. And this one is one of the most important ones. Besides parcel identification number and pixel count, it can give us all the informations about crops which we have on those fields. For example, maize. Maize is a British term for corn, which is more American. I guess Oscar used this term a lot. And soybean and all other classes which you can see here, they were conducted with this analysis. And besides that, I got time series data of all of those images from December 2020 up to September 2021. And it was the data containing informations about those B features converted into, again, pixel format. And a lot of information about soil properties, pH level, nitrogen level, clay, and so on. And now, after I got this data, I needed to see how crops are distributed to see how will I do the analysis. And I plotted these graphs and noticed that maize and wheat are in total covering more than 50 percentage compared to all other classes, and that we have imbalanced data. And now, with this information, I needed to choose next steps and to see which of those time series data will I start. And have in mind that, okay, it's good if if it's just one. And this is your favorite part. Yes. I asked myself at first when to sow and when to harvest corn and wheat, because at that point I was not familiar with agriculture at all. I just knew how corn looks like and nothing else. So I decided to call my brother, who is a farmer, and to ask him this question to get a better impression of how to start my analysis. And he gave me the answer, but this was not enough for me at that point because it was still covering a lot of months. And then I decided to use my logic and to ask myself, should I start from summer months? Why? Because it's usually a peak growing season for almost all of the crops, and they are more visible from the satellite. Plus, summer, we don't have cloudy weather, we don't have snow cover, so that was also one of the reasons to start with it. And I think I chose at first July, August, and September. Now, when data was prepared, I needed to choose the algorithms which I want to use. And between machine learning models, I almost use all of them. SVM was stopped because it was too slow and I could not run it on my laptop, but all others were tested. And beside machine learning algorithms, I decided to use also deep learning algorithm. I developed my own convolutional neural network, starting to build it from scratch with just adding some of the dense layers. Later, I added convolutional 1D layer and more dense layers. It gave me higher accuracy, but still not high enough. And then I was adding some special techniques as max pooling 1D, batch normalization, drops outs, and so on. But this is a separate topic. It was not included deeply in my master thesis because focus was more on machine learning algorithms. And you will see soon why. This resulted with developing almost 300 models using mentioned algorithms, but just changing parameters. Why? Because this was a Kaggle competition. Kaggle, I think a lot of you know, but if somebody doesn't know, it's a page where you can insert your evaluation to evaluate your model objectively, to check the accuracy of the algorithms which you were testing. And it started as just small competition at first, actually as a hackathon, where my professor Oscar invited me and some of colleagues to join. And it was horrible because we just started to learn Python and we had 11% of the accuracy, which was super low at that point. And then later at my faculty, I decided to continue with this topic. And the final score from 11 points, from 11, yes, percentage, sorry, went to 94 almost with random forest. And that was evaluated with macro F1 score, which is usually used for imbalance type of the data. And all other algorithms also provided a solid foundation for this classification problem, but naive Bayes was maybe a little bit naive compared to the algorithms above. So given that random forest gave me the highest score, I decided to use it for the next really important field of analysis, which is explainable AI. And finally, AI with actually AI in presentation, not just in topic, not for the previous speakers, but usually we were talking about that after HeapCon and some other conference that they want to put AI in the topic, but actually not to use it. And that's why I think this is really important to understand because some of the people are not familiar with this area, and it really can help us to understand the algorithms, which are black box. So we don't know what is happening in the algorithm, why the output is exactly like that. Here on the first example, we just have image of the butterfly. If we put it in algorithm will do something and give us output that this is an insect. But we don't know why. Was it just a lucky guess, or was it true how it got that answer? And this is where AI, actually explainable AI, steps in, because you can put the question why and you will get an answer. In this case, it could be it has 6 legs, so that's why it's an insect and not human or whatever. And how I used this field, I plotted different graphs using SHAP library in Python. SHAP is usually a library for machine learning models. And this looks super easy, but it was also hard for me while I was learning to, in the end, achieve those results and to actually extract the information from them. And if you look at, for example, these features before 5 and 6, you can see how they are affecting the output of the model for almost all of the classes, especially for the blue and orange one, which are maize and wheat, and those were the most dominant classes which we had. Uh, and a little bit about B8, for example, it's not giving us a lot of information about output, how it's affecting the output of all the classes. And you can do those graphs for each crop type separately. So here is sunflower, and how we can read those graphs. If the color is blue, then they had a lower impact on the output of the model. And if they are more starting from purple up to pinkish, they had a larger impact. And also, if they're right from the zero on the center, they had a positive impact, and on the left, more negative impact. So we can do this. I did this analysis for all of the crops, and it was in the end huge to read all of those results, but it really helped me. And the last point, how you can, not last, but last, which I use, is to measure average impact on the model output, where larger dots are indicating the larger output and smaller the opposite. And we still here can see that a lot of dots are concentrated around those B4, 5, and 6 features. And this area is really important, not just in agriculture, but in all the aspects. Even in media, we need to understand, as Karen also mentioned, hallucinations, or what is behind the model. Is it giving the good output or not? For the doctors, if they want to read results, you cannot just deliver to them your code and say, oh, algorithm told me that your patient might have this disease. Of course, they will need to understand why. And this is how you can explain to me, based on, depending on which disease, for example, they want to track. You can see blood sugar was super high, and all other results which those graphs will give you. So to conclude the story, in the end, I developed almost 300 models using Mention algorithms, where random forest stood out with the highest macro F1 score. And we saw that spectral bands really can affect our results. And this can be also compared with, for example, because I was mentioning a lot B4 and B5 features, they can capture the informations about the health of vegetation and the level of chlorophyll content, which can help us to classify different types of the crops. So that's why this was useful for me. Explainable AI is really here to help us, so we should use it, but carefully look at the results and the methods while we are achieving this. And we saw the benefits of satellite images and how we can use the Copernicus, but we need to be careful, because as everything, this can also be misused. How, for example, if we are looking at military purposes, they can track from the satellite images where their food supplies and target exactly that. Illegal farmers can find protected and security areas to grow up cannabis or poppy. I will check on the image data. Do we have those areas near Begay River? And of course, government politics can manipulate with information about the crops and the predictions. So this, in the end, can affect us all. But I would always stick with traditional methods, but just use AI where it can definitely retain the same quality or even get the better one, but in the end, to optimize the time. That's it. Yeah. Just to mention, this is a QR code for my master thesis. It's written on English, so if somebody wants to get more technical details, you can scan it.
Great. Thank you, Mitsu. Oh, guys, do you have any questions? My microphone. Anybody? Yeah, you do left us speechless. Except me, of course. I have to say something. No, when I first hear the presentation, I mean, I was thinking about my family, and I was just trying to figure out how I would explain to my family to actually use some of this data. So how to bridge the gap between, high level technology from one point of view, and the other side is like, I mean, agriculture is like traditional field. People are usually not that tech oriented. So do you have any particular advice?
I think Oscar will talk about this soon.
Okay.
But what was my problem when I started talking with my friends who were farmers? Even with COVID vaccination, that they thought that somebody will track them up 24 hours. So to establish that research part, to put it into actually productive area is, I think, still hard, at least from my perspective. But for a larger companies that usually have this impact and doing the projects in that way, I think it's possible.
Okay, I can repeat the question I got from the audience, not publicly, but they asked if it's possible to hide the crops from the satellite. I will not ask why.
No, maybe in those protected and sensitive areas, yes. But in general, that's also one of the problems with these misused parts, because from ethical perspective, they can feel vulnerable with all those information if they're not willing to give them, but somebody already have them. So, yeah, problem.
Okay, so whoever asked, you got the answer. Yeah, just a second. This one should. Uh, okay, it should work. The
Thank you.
second microphone,
Uh,
please.
I just wanted to ask how did you implement explainable AI model?
With
How did you connect it to the black box?
with that SHEP library. So if you take the predictions of the algorithm, which was in this case random forest, and ran them through this SHEP library, you will get those answers and those graphs. And there is a special technique for deep learning models. I think it's called integrated gradients method, which can also then reveal the predictions of those convolutional neural networks or whatever else.
Thank you.
And this was included also a lot of pre-processing techniques, but didn't want to go into too many technical details, but just some of the standard ones: standardization, normalization, running a smooth algorithm to achieve more balanced data, which gave me synthetically generated data, and so on. So I know you're curious about it. We can discuss also
Okay, thank you. Thanks.
additionally.
Perfect. Yeah, we have one additional question. We'll just run. Here you go.
First of all, great presentation. Can you explain us a little bit more why did the random forest give you the best result for this?
We are laughing because this was my question on this was a question on my defense. I got it from Oscar, and I was more focused on the random forest because I had information during hackathon that it can achieve the score of more than 90 percentage. So it was in this case secure to choose it and to just try to achieve the high score. But I'm pretty sure with adding additional techniques to convolutional neural network, you can achieve the similar results.
Thanks.
Anybody else? Yeah? You will just wait for a second. Okay, next year I need volunteer for this one.
Great presentation, thank you. I just have a two-part question. First off, I was wondering about the machine learning part. Since you mentioned all of these algorithms, how much time did you have to focus on hyperparameters and actually fine-tuning the algorithm? Since you made so many models, I assume you did a lot of it. And also the second part, I really appreciated how much you focused in your thesis. I presume I will for sure read it on the explainable AI part, since I'm running into that problem in my work as well. And I was wondering if you accidentally came across something in the explanations that you weren't thinking was logical, or you maybe found a new insight since you don't have a background, as you mentioned, in this topic, if there was something that surprised you in the explainability of the models and variables.
Great questions. At first, as I mentioned, while this was a Kaggle competition, we had I think 1 month to develop the high score. But in the end, I was a student. I waited the last 2 weeks, and then I was doing this without sleeping 20 hours literally. And there I developed 140 models, not approximately exactly, because I had a limit on the submissions and I could not add more. But then later I asked my professor to leave me open Kaggle page to insert additionally those scores, because with 2 weeks I got I think 88% of the accuracy, and I wanted really to be above 90. And then I inserted double as that in like 3-4 months periodically. And for explainable AI, definitely. It all confirmed what I saw from distribution, that it will be really important to focus on those B features, B4 and 5. And after researching that, that they are giving me a good solid foundation for different chlorophyll content and to distinguish between different crop types, then we explainable AI just confirmed that it's a good way to use those features. And it also helped me to exclude some of the features like B8, which was not affecting the output of the model almost at all. And that also resulted in a higher score. So it helped me definitely practically, also not just logically.
Thank you.
Do we have more questions?
I have a question.
Okay. This is new. Okay. This is not planned.
This satellite is super interesting, so we are curious to learn how the informations are often updated. Is it on weekly or monthly basis? And I would say 5 days.
So for your speech, it was great, and
Thank you, and
see you
thank you for
next
your
year.
time.
Yes, see you next year on the TX conference.
We will see.